Welcome back to our YouTube channel Aman Codes. In today's episode, we are going to discuss about OR operator in logical operators. So let's see the syntax. Relational expression 1 or relational expression 2. So by using this OR operator, we are going to evaluate these type of logical expressions. The functionality of OR operator is given the following. So in previous episode, we have shown the truth table of AND operator, right? So in today's episode, we are going to discuss about OR operator's truth table. See here, relational expression 1, relational expression 2, relational expression 1 or relational expression 2. So if relational expression 1 is true or relational expression 2 is false. See, relational expression 1 or relational expression 2, right? So true or false. So in this, the answer is true. Why in the sense? It is also going to use some rule. So here see, so internally true is treated as 1 and false is treated as 0, right? So 1 or 0 or 1 plus 0, the answer is going to be 1, right? So this OR operator is going to work on this principle, addition principle. So see here, next false and true. So internally false is considered 0 and internally true as considered 1. So by do this sum, the answer is going to be 1 in the sense true. See here, right? So the next thing is false and false. It is known as false. So 0 plus 0, 0, right? So true and true. Here comes the thing. So internally true as considered 1, internally true as considered 1. So 1 plus 1, the answer is 2 normally, right? So in 8421 code, if we want to represent 0, we are going to represent like this, all zeros. So if we want to represent 1, we have to represent like this, all zeros and last at place of 1, we are going to represent 1. So in this 8421 code, if we want to represent 2, then we are going to declare like this, 0, 0, 1 and 0. See here, at the place of 2, we declared 1, right? In the sense, where the positions we have declared, we have to sum that position. See here, I have declared 1 at a position of 2, right? So 2 plus this all zeros, it's considered as 2. So in order to declare this 2 in our truth table, we are going to declare like this 1 and 0 is normally 2, right? So 2 is a non-zero. Non-zero in the sense it is true. In this R truth table, 2 has represented in this manner and you can consider 1 0. So at the place of true, we have to write 1 0. So what is 1 0? 1 0 is 2, right? So 2 is a non-zero. Non-zero in the sense true. So that is the reason we have represented here true. So let's see the short circuit evaluation in the case of OR operator. So we have seen short circuit evaluation in the case of AND operator, right? In previous episode. So quite reverse engineering is going to be done here. So see here, if two or more relational expressions connected with a logical operator OR, so I'm going to declare relational expression. See here, A greater than B is my relational expression and B greater than C is my relational expression. So for these two relational expressions, I have to declare an logical operator. So here I am going to use logical operator called OR. So these are the relational expressions. These are the logical operator. Two or more relational expressions are connected with logical operator OR. Then it is known as logical expression, right? So, and if initial relational expression evaluated as a true. So if this initial relational expression is evaluated as true, then what happens? Then PVM will not evaluate rest of subsequent relational expressions and the results of the entire relational expression is considered as true. See here, if the first relational expression is considered is evaluated as true in a sense, then the remaining subsequent relational expressions is not going to be executed or evaluated so by PVM. So the entire result of this logical expression is going to be true. So this process of evaluation is called short circuit evaluation. Let's see the practical examples in this OR operator. So see here, we are going to check whether this truth table is right or wrong. So I'm opening Python command prompt. See here. So now I'm going to enter true or false. See here, true or false, right? So the output is going to be true. So here in this case, the short circuit evaluation has been done, right? So if I declare like this, false or true, then the output is going to be true. So here full length evaluation has been done by C. Here first is false. So then it is going to next subsequent relational expression or value. See here we have what? We have true. So then the output is true. So if I declare like this true or true, the output is going to be true. So if I execute this thing false and false, the output is going to be false. See here false, right? So here the outputs of truth tables are, so see here true, true, false, true, right? See here true, true, false, true, right? So this is the level 1 examples. So 10 greater than 2 or 40 greater than 50. See here we have 10 greater than 2, right? It is going to be true, right? So then PVM is does not execute the rest of subsequent relational expressions. So the entire logical expression output is going to be considered as true, right? So this is short circuit evaluation. So let's see the output. See, the output is true, right? So that is the reason these examples are important. So if I consider this thing, then output is going to be true only. See, why? Here only true. Then PVM does not consider this all subsequent relational expressions, right? So if I consider this example, 10 greater than 10 or 40 greater than 30 or 56 greater than 66, 10 greater than 10 is going to be false, right? So when the first relational expression is going to be false, then the PVM is going to evaluate. So the next subsequent relational expression. See here, this is 40 greater than 30. So it is true. Then when it is true, it is not going to evaluate the next subsequent expressions. Then the output of this entire logical expression is going to be true. So this type of evaluation is known as short circuit evaluation, right? So try to see the output. The answer is going to be true, right? So see here, if I consider this thing 10 greater than 10 or 40 less than 30 or 56 less than 66. So see here, 10 greater than 10 is going to be false. Then PVM is going to execute the next subsequent expression is known as 40 less than 30. So it is going to be false. 40 is not less than 30, right? So then PVM is going to evaluate the next subsequent relational expression. See here, 56 less than 66. So 56 is less than 66, right? So here the answer is going to be true, right? So the output is going to be true. So this type of evaluation is known as full length evaluation. See here. So the output is true, right? So in the case of less than, if I declare here greater than, so it is going to be false, then the output is going to be false. This type of evaluation is also known as full length evaluation. So this type of examples are level 2 examples. So if I consider level 3 examples, so if I consider these examples, 100 or 200, 100 is a non-zero value, so then it is considered as true, right? So whenever the first relational expression or the first value is going to be considered as true, then the PVM is not going to execute the rest of subsequent relational expressions or values. Then the entire logical expression output is going to be considered as true. So here the output is not in the form of true. So the output is going to print 100. Why? In the sense we are going to use these values, right? So we are not using the relational expressions. We are using the values directly. That is the reason the output is going to be 100. So I'm trying to execute this statement. So see here, the output is 100, right? So it is going to evaluate short circuit evaluation. So 10 or 0, the output is 100. See here 100, right? So if I do this thing 0 or 130 or 34, try to guess the outputs. So the output is going to be 130. See here 130, right? So why? So 0 is false. It is going to be executed the next subsequent relation expression or value. So it is true. So then it is not going to execute the remaining. So the what is true that is going to display here. So this type of evaluation is short circuit evaluation. So 0 or 0 or 0. Then the output is going to be 0. See here. Why? It is false, going to execute another, false, going to execute another. False. Then the output is false. In the sense, output is 0 has been retrieved, right? So in the place of 0, if I use 123, then the output is going to be 123. See here. The output is 123, right? TVM is going to evaluate this 0. It is considered as false. Then it is going to next subsequent relational expression or a value. See here, it is also false. So why it is false in the sense it is a 0. Internally 0 is considered as false, right? So it is going to evaluate the next subsequent relational expression or value. See here, we have non-zero value. Non-zero value in the sense true. So the true is going to be get output. So here in place of true, we have the value, right? So that is the reason we got the value as an output. So this type of evaluation is known as full length evaluation. So if I use this strings, if I going to use this type of statements, Python or Jython or DSA, so the output is going to be retrieved as Python. Why? In the sense, so in string, it is going to be considered as length of string. So the length of string is non-zero, then it is going to be true. If the length of string is zero, then it is going to be false. So here the length of string is 1, 2, 3, 4, 5, 6, right? So the length of string is 6. 6 is a non-zero, then it is going to considered as true. So when it is going to consider true, so the remaining subsequent relational expressions or values is not going to be evaluated by TVM. Then the entire relational expressions output is going to be treated as true. So here we are used the value called Python, right? So that is the reason we got the output as Python. So the output as Python, right? So in case of AND operator, it is going to retrieve the output as DSA. In the case of OR operator, the output is Python. So if I declare like this, see here, if I declare here empty string, then the output is going to be Jython. See here, Jython, right? So empty string considered as false, then it is going to execute subsequent relational expression or value. So the length of this string is non-zero, then it is going to consider as true, then it is going to print Jython here. So if I try to do this thing, here also I'm going to put an empty string. Then the output is going to be DSA. See here, DSA, right? So here also if I do this thing, the output is an empty string. See here, single quotes, there is no values. So if I do this thing, the answer of this 2 or 4 or 6 is, try to guess, the output is 2. Why in the sense, 2 is a non-zero value. Non-zero value considered as true, right? So here we have declared this value. So the value is going to be retrieved. Answer is 2. See here, 2, right? So this is a short circuit evaluation. So try to answer this. The output is going to be 6. See here, 10 minus 4 is 6, right? 6 is a non-zero value. Non-zero value is treated as true. 6 is going to be print. The output is 6, right? 6 has been retrieved, right? These type of examples are level 3 examples in this OR operator. So these examples are really important when you are attending an interview. So in this episode, we have discussed the OR operator in this logical operators. So that's all for today's episode. I hope you all understand. Don't forget to like, share, and subscribe to Aman Codes. Thank you so much for watching.